Okay, we're going to start back off at number 12 there. I got cut off a little bit. We want to get our equation in the form ax plus by minus c equals 0. We have an x-intercept of -3 and a y-intercept of 4, which gives me an ordered pair of -3, 0, and a y-intercept of 0, 4. I'm going to start out by putting it in point-slope form. Y minus y1 equals m times x minus x1. I need to find the slope. Y2 minus y1 over x2 minus x1. So the difference in the y's would be 4 minus 0 over the difference in the x's, 0 minus -3. And that gives me a slope of 4/3. So I'm going to use my slope of 4/3, and I just want to pick one of the points. I'll use the first one to be my x1, y1. I have y then minus 0 equals m, which is our slope of 4/3, times x minus -3. This is going to simplify pretty easy. I have y equals then 4/3 x plus, that's going to be a positive, 4/3 times 3 is 4. Because I want it in standard form, I'm going to bring all my terms over to the left side of the equation. So my x term and my constant term will both come over. That gives me -4/3 x plus y minus 4 equals 0. And we said our rules for standard form were that we didn't want any rational numbers, or at least fractions. So no fractions or decimals, only integers, and that the first coefficient has to be positive. So to help me with all of that, I'm going to multiply both sides of the equation by negative to get rid of the negative, and a denominator of 3 in that rule to get rid of my denominator. The result is going to be 4x minus 3y plus 12 equals 0. That's my standard form. Number 13, we're going to determine whether the graphs of 3x minus 2y minus 5 equals 0 and y equals -2/3 x plus 4 are parallel, coinciding, perpendicular, or none. Remember that parallel have equal slopes, coinciding have equal slopes and equal y-intercepts, and perpendicular lines have negative reciprocal slopes. So we want to focus on the slopes of the lines here. I'm going to put them both in slope-intercept form to help me out. So I already have the slope of the second line is -2/3. I just need to see what the slope of the top line is going to be. So I'm going to put it in slope-intercept form. I have 2y, the 3x and the 5 are going to go to the right side of the equation, minus 3x plus 5, divide by -2, and that's going to give me an equation of y equals 3 halves x minus 5 halves. So if I take a look at my slopes here, I have -2/3 and +3 halves, which are opposite signs, and they're reciprocals, so I actually have perpendicular lines. Number 14, I want to write in slope-intercept form, so y equals mx plus b. The equation of the line that passes through the point -6, 5, and is parallel to the line, so parallel to the line x minus 3y plus 6 equals 0. Parallel lines have equal slope, so I'm going to find the slope of this line, and that will be the slope of the line that's parallel to it as well. -3y equals 6 divided by -3. Y then is going to equal 1/3 x plus 2. And there's my slope. So the slope of my parallel line is going to be 1/3 as well. So once I find the slope, I really don't need that other equation anymore. I'm going to write an equation with this information. Again, I'm going to use point slope form. I think that's the easiest way, and then solve for y to get it in y-intercept form. Y minus y1, which is 5, equals 1/3 times x minus -6 would be plus 6. And we'll do a little simplifying. Y minus 5 equals 1/3 x plus 2. Add 5. I get y equals 1/3 x plus 7. And that's the slope-intercept form. Number 15, I want in standard form. Ax plus by minus c equals 0. Write the standard form of the equation of the line that passes through the point, -2, 3, and this time is perpendicular to 2y plus 6 equals 0. So I want the reciprocal, or they need to be negative reciprocals, the slopes do. I don't have an x here, I'm just going to solve for y. That's 2y equals -6, y equals -3. That tells me that I have a horizontal line going through -3 on the y-axis, and horizontal lines have slope of 0. So the slope is 0. If I want a line that's perpendicular to that, it's going to have to be a vertical line. And a vertical line has no slope. A vertical line equation is strictly going to be based on where it crosses the x-axis. So in that case, all I need is the x-coordinate of the given point, and the equation of my line then will be x equals -2. Now actually we want that in standard form, so all of my terms need to come over and the equation needs to be set equal to 0. So if I bring the -2 over, I'm going to add 2, I get x plus 2 equals 0, and that's the equation of my vertical line in standard form. Number 16, I have a laboratory tests, a new fertilizer by applying it to 100 seeds. Write a prediction equation in slope-intercept form for the line of best fit. We don't have to do the line of best fit. We just want to write an equation in slope-intercept form. Y equals mx plus b for the points 1, 8 and 6, 98. So let's start by finding the slope. Subtract the y's, 98 minus 8, and subtract the x's, 6 minus 1. You get 90 over 5, which is a slope of 18. So the slope is 18. I'm going to use that in one of the points and put it in point slope form and then simplify to slope intercept form. So y minus y1, which is y minus 8, equals the slope m times x minus x1. We'll simplify that. Add 8. Y would equal 18x minus 10. And that would be an equation in slope-intercept form to predict the data. I'm going to go back to full screen. To a single page, sorry. and we'll look at graphing absolute value. Get the picture just the right size. And for number 17, I want to graph the function. I have -2 and the absolute value of x. So what I'm going to do is make a little t-chart for number 17. And I'm going to have my x values, and then my output value, which is my y, or my f of x, is -2 times the absolute value of x. So we're just going to make a t-chart and then plot those points. I'm going to pick some negatives and some positives. I'm going to put -3 in for x, but the absolute value of -3 is 3. So I have -2 times the absolute value of -3 is actually going to be -6. And then for -1, I have -2 times the absolute value of -1 is -2. I put 0 in, I get -2 times 0 is 0. -2 times 1 is -2, and -2 times 3 is -6. So I have a set of ordered pairs, and I'm ready to graph that. I'm just going to plot the points on my coordinate plane. I have -3, 6, it's about right in here, or I'm sorry, -6. -3, -6, about right there. I have -1, -2, 0, 0, 1, -2, and -3, -6. And so it kind of has a little upside down V for my absolute value. For number 18, this is a step function, and if you recall, we have our x values and we have our y values, and the x values are actually an interval. The interval, let's say I start with negatives, and I have -1, so that x is greater than or equal to -1 and less than 0, and my output then would be -1. If I have x is greater than or equal to 0 and less than 1, my output would be 0. And if I have 0 or x is greater than or equal to 1 and less than 2, my output was 1. I don't have x this time, I have x minus 2. So where I see the x, I'm going to fill that in, and I'm going to say solve this little inequality by adding 2 to all 3 sections of the inequality. And that gives me x is greater than or equal to 1 and less than 2. But my output stays the same. Same thing for the next one. I have x minus 2. I'm going to add 2 to all 3 sections, and that's going to give me x is greater than or equal to 2 and less than 3. And add 2 again, I get x is greater than or equal to 3 and less than 4. Each time my output stays the same though.